All right, welcome back. We're going to take a look this week at the first step after we have our mix sort of roughed in terms of the session pulled up and the tracks grouped and organized, and the waveform set to our preference so that we can see the totality of the track as well as enough detail and get functionality with those zoom controls. So when we look at EQ, it's the first real modification of the raw signal that we've got, and it's important to remember that every detour we propose to that signal does potentially threaten it, as well as, it's a double-edged sword thing. There's positives and negatives to every situation. So we need to understand how to maximize the positives and make minimalist, economic adjustments to bring out the area of, the tone, of the instrument that we are wanting to insert into the mix, and also maybe another adjustment to minimize some aspect that is making it more difficult to fit into the mix. So as we mentioned in the first week, mixing is just one of the EQ is one of the three dimensions of when we consider what a mix is. So the left and the right being the x-axis, using the panning in a stereo situation to kind of shift an image around from left to right, or on the horizontal x-axis. Level being sort of vertical adjustment of what is high, what is low in the mix. And then EQ falls into that interesting sort of z-axis, so what brings it something closer or further away. Reverb and delay also work in this way to suggest a certain amount of distance or proximity. EQ is relative to pitch, like correlative, but it's not identical to pitch. And so, EQ, is best thought of in terms of a tone control, so manipulating energy that's already present within a sound to bring out or kill, cut or boost, say, treble frequencies or low frequencies, but we're not actually modifying the fundamental musical note. And so we're not changing the wavelength, we are just changing the harmonic content, I guess you could say. Different types of EQ, some of the most common you might find on early guitar amplifiers, or even a home stereo type of a unit where you've got just bass and treble. There's a preset frequency range that is being identified by that unit, whatever your stereo might be, even a car stereo, and it'll bring up that entire range from say 20 hertz all the way up to 200 hertz for the bass is a common cutoff position, and 200 to 2K for treble, for mid-range, and 2K to 20,000 or 20K for the treble controls. That would be how to divide it into three relatively equal domains, but in any case, you're just adjusting an entire block of frequencies there. Semi-parametric gives you another way to get a little bit more control and focus over the situation, and so you can actually dial in a specific frequency. Neighboring frequencies will be arranged affected somewhat like shelving, but not as much, not an entire block. So anyway, you're selecting a center frequency, and then you can either cut or boost that with a different control. And so instead of just one control knob that you turn for bass to turn it up or down, now you've got a two control situation. So we can kind of look at that. So on the right hand side, you see the center frequency is the middle button. What you're actually seeing, there's a fully parametric EQ. But if you didn't have the bottom control that says bandwidth, and you just had the middle control that says center frequency. So right now it's at 400 hertz. And then you can see that it's being boosted up to, looks like 6 dB. So that's a basically semi-parametric. When you go full parametric, now you get to control how much of that shelf, how much of those neighboring frequencies are getting affected as well. And so in the bottom image there, B, you can see that you can be very narrow with a Q of 10. The Q is quality control or precision of frequency range specification. You're only going to be affecting that 1K. So you can see across the bottom is the frequency, and on that bottom graph, the left-hand side is decibels of reduction, and on the top is the Q control. So this is a Q of 10, meaning you're very, very specific. You're being surgical here. And as you roll that Q out to 0, it becomes, you're affecting a lot of different frequencies around there all the way. It looks like you can get down to 200 hertz, or so, with, much more minor sort of impact there. And so that's, semi-parametric and parametric is really the difference of one more knob. So your fully parametric EQ will have 3 knobs as opposed to 2 for the semi-parametric and just 1 for the shelving. So here is a look once again, fully parametric on the left. You've got your frequency ranges, so kind of higher frequencies, 20K down to about 8, and then on the middle knob you have I guess those are all frequency ranges. That's not cut and boost. On the middle knob you have your mid-range. On the second from the bottom knob on the left, you've got your lower frequencies, and then you have a separate control in blue there that's indicated to specify how you want to impact those frequencies. Slightly more simplified version of that is the gray, the horizontal EQ there, where you've got low frequency. Well, first of all, high pass filter, we'll get to that in a second, but then LF for low frequency, LMF for low mid frequency, HMF for high mid frequency, and HF for high frequency, and that's just reading across the top of that control panel. And then you can see very simply right under those designations, the first knobs across the top from right to left, those are all cut and boost. And so at 0, that's unity gain, meaning it's transparent, the EQ is not doing anything. If you turn it towards plus, you're going to boost. To the left is the cut. And then on the bottom, there's where you get to dial in your exact frequency. So those are semi-parametric. High pass and low pass filters, are basically designed to rapidly eliminate an entire area, sort of like with the push of a button instead of the turn of a knob. So they're very quick. For example, recording vocals, you're not going to have much energy past, below 100 hertz, for example, and that would already be very, very low for a male baritone voice, or pretty low, I'd say. And so what you can do is, if you hit a high pass there, that means that it's going to cut the low. And so a low pass will cut the high. So those are just two ways of reading the same thing. But, and back to that example of the voice, you're letting the frequencies that are actually present go by, and you're eliminating the low frequencies. So a high pass will cut the lows out where you've got just potential garbage noise, maybe air conditioner rumble, or there's a truck on the street in the distance, or noises that you may not even perceive that are low and creating problems in your mix. Okay, so as we mentioned, high pass is low cut, low pass is high cut. These are just very common buttons that you'll see, and they oftentimes have these diagrams on there. So, on the left-hand side, you can see that's a low pass. and so it's rolling off on the high. So you're not going to have, if the diagram reads left to right, left is low and right is higher frequency. So going from 20 hertz to 20,000, you're keeping what's in the box and you're losing the rest. And so the opposite will apply to the top right-hand diagram, where you can see if you're keeping what's in the box, then it's those low frequencies that will slope off and be cut out. So it's a high-pass filter. And then you've got band pass or band stop or reject, which are basically like mid-pass or mid-cut filters. Those are less common, but those diagrams will help you more clearly understand what is going on there when you read them in terms of EQ. And finally, the graphic EQ. These are oftentimes used for monitors, like at side stage in a live sound rig, where you can easily, call up a specific frequency and notch it out. So based on how many bands it is, this looks like a 32 band EQ. With the left-hand channel on the top and the right-hand channel on the bottom. So it's a stereo 2-channel EQ. It's arranged there so it looks like a smooth kind of wave or rolling hills, but that is not any sort of setting that you would actually see unless someone was just being a little bit fresh and cute. In any case, this is a good, use a graphic EQ to teach students how to ring out monitors, for example. So you put everything flat like you see on the bottom one, and you just keep on turning the monitors up next to a live microphone until something starts to feed back. And when it does, you try to guess about what range it is. And you pull, when you identify it, you pull it back and you turn it up again, and then you've got your monitors are in tune for that room. These are kind of EQs you can pull up on iTunes, for example, and play around. There is a graphic EQ on there. They have vertical slider adjustments that catch in the middle. So 0 dB is neither boost nor cut. That's unity gain. And so the unit can be on, the EQ can be on, but if it's at 0 in the middle there, like the bottom one is, then there'll be 0 audible effect because it's not doing anything. It's like the transparency setting. And then, from left to right, that's 25 hertz up to 20,000 hertz. And so you can read it from left to right, low to high frequency. And then if you push it above unity gain, you're boosting it. And if you draw it downward below unity gain, you're cutting it. So you can see on the top setting that 200 hertz is cut all the way. It looks like it's a 15 dB cut, so it's pretty powerful. Whereas 800 hertz is boosted all of the way, so it's at plus 10. So that's how to read and operate your graphic EQ. Okay. Generally speaking, it's not a pitch corrector. It is useful for controlling how a poorly designed audio space, like a gymnasium or something that you're setting up sound in that's not designed for sound, is going to give you some problems at different frequencies. And so EQ is a great way to help even that out. Some control rooms are, also have issues. Monitors and stuff, as I mentioned before, is another good application. But it has no effect on, effects. So if you've got too much reverb, not going to help you, too much distortion or echo. You've got other ways to address that, but EQ is not one of them. It can create the perception of loudness. So if you bring up, 10 to 12,000 hertz, that very sort of top end of the treble, or higher treble, I should say, you do get it triggers in your brain that something's very close to you, because you can only hear those frequencies when somebody's like whispering in your ear usually, because those high frequencies are very short wavelengths and they are deflected and absorbed the easiest of the entire spectrum. So we're not used to hearing that except in those situations. So, for critical listening, you want to, try to identify the core frequency of a sound. That's a good exercise to build your conversational ability when you're talking about EQ, which, once again, this is like one of the most fundamental steps to achieving a good mix is to, find those one or two adjustments that are going to bring your instrument into blossom and eliminate some sort of problem that's fighting the mix. So it's not the instrument in itself. We're not listening in solo for everything. We are, listening to it in solo and then listening to it in the mix and making educated guesses about what's going to work here. And so when you talk about, EQ, you want to indicate the frequency and then how much cut or boost. And so I'm going to boost 5K by 3 decibels is a meaningful sentence in, when you're communicating EQ adjustment to either me, a classmate, or especially in the workplace. It's typically, unless you're doing mastering, tethered to an instrument or part of a mix, like your entire drums, you can mix together and then adjust them. We do have an exercise on using onomatopoeia, which is, sounds that sound like what they're talking about. And so, sibilance is that very high frequency or something that's boomy. They correspond to the high and low frequencies because of the sound that those words actually generate. So I want to give the vocals more presence, so boost them by 5K at 10 dB. Talking about attack, sustain, release, is another way to be specific about what you're trying to do to a sound, the envelope. And finally, this is a really useful map just to show you how mixing is like potentially like putting puzzle pieces together, and EQ is kind of the glue that allows them to kind of be good neighbors. And so when I am approaching a mix, and EQ is something that I tend to spend a lot of time on. I will identify the core range where a given instrument belongs. And so if a given instrument is, say I'm using, electric guitar, and its energy is between, we'll just use, the one on this picture here. Let's see, where is it? Strings, electric guitars, there it is. So it's coming in at about 80 all the way up to, 1.5K. And so if you take that range and divide it into 3 even, subsections, that middle section is going to be your core area. And that's where there's the most balanced representation of the entire range. And so you kind of want to recognize and respect and value that, and use the other two, the kind of low part of that guitar, the high part of that guitar, to really treat it as the overlap area of whatever else is going on that's also in that area. And so that's where you have to make the decisions of how you're going to glue this thing together, which will be louder, which will, have reverb to sit in a certain, relative to its neighbor. There are a lot of different ways to kind of address this, but what I want you to do is to first of all just recognize it. Another way to look at it is like by mapping. Each instrument has its relative zip code, and so we need to kind of pull all those together and show the map of the city. And so working on the overlap areas to help, help the mix fit together is, what we'll be talking about with processing and effects and subsequent sections of this class. and some instruments, like you see keys at the bottom, are synthesizer. It's almost the entire, range. They go below 20 hertz, obviously, and above. And so there you just, you've got to make decisions and be